inside water has a refractive index 4/3 when viewed from air in a vertical direction appears to be raised by 2 mm. Find the depth of the coin in water. So first let's draw this. Okay, there is a container and it has got water in it. Coin is kept here, but it looks where? It looks as if it is raised here. Fine. Now this is the dotted line. Fine. Means it is not the actual one. Refractive index of this one is mu of this water is 4/3 and this is air. So it has been raised by 2 mm. So this distance is how much? 2 mm. They're asking the depth of the coin. So we have to find out this length, the depth. This is, let this be x. Okay. So what is the formula for depth? And this is the basically apparent depth, right? Now this is the shift. It has been raised by this much. This is the shift they have given here. Fine. And this is the actual depth. And this is the refractive index they have given here. Okay. We have a formula for apparent depth. And what is the formula? Apparent depth is equal to real depth upon refractive index of water here. Apparent depth, do we know it? We do not know, right? We know the shift here in it. Okay, so apparent depth here will be equal to real depth is as we had taken as x, and refractive index is how much? 4/3. So this will give you x divided by 4/3, which will give you x into 3/4. So that is equal to 3x/4. This is apparent depth. Apparent depth. Now once we have got the apparent depth, we have to use, we know that they have given the shift. This is 2 mm is a shift. So you can write the given here. Shift is 2 mm. And real depth we have taken is x mm. Fine. And apparent depth we have got is how much? 3x/4 mm. Now what is the formula of a shift and real depth and apparent depth? Do you know that? Shift is equal to real depth minus apparent depth. So what is the shift? They have given the shift is 2 mm, so you can write it 2 mm. So simply write 2. Real depth x, apparent depth 3x/4. Solve it. So 2 is equal to 4x minus 3x/4. So 2 is equal to x/4. And then we can solve it. What we'll get is x is equal to 8 mm because it was mm. And what is x? X is the real depth. So real depth is equal to 8 mm, and this is the answer here. Fine. So understood how to solve it? We have to first we have to find the apparent depth. It will come in terms of x, and once we have got it, okay, shift is given, real depth is given, apparent depth we have found it in terms of x. There is a relation between the three, that is what? shift is equal to real depth minus apparent depth. Put in the formula, form the equation, solve it, you will get the value of x, and x is nothing but real depth, and that is an answer here. Okay.